And then I'm actually going to share my screen, I think. Okay, so when we were just getting started, I mentioned several goals that we have to keep in mind when we are writing our computer programs. And I'm just going to review them real quickly here. We want to make our programs, actually, let me just, easy to read and understand, easy to debug, easy to modify and maintain, easy to reuse parts. So, and the reason I'm just throwing those up here again is because basically that's what is behind functions. You know, theoretically, we could write all of our programs, you know, 10 million line programs, whatever, without using any sort of functions or other sub-programs. But we use them a lot, and these are the reasons why we're using them. So that's just an encouragement to, as we are thinking about how to use functions in a productive way, this is sort of the goal we have in mind. So one analogy I like to use is that it helps to think about functions as modules, much in the same way that in a computer or any sort of electronic equipment these days, you have these modules, I'm going to call them, that are sort of pieces that you can plug in and pull out, right? So it's pretty rare to have a piece of electronic equipment these days, TV, whatever, where you would actually get it repaired, say, by going in and maybe moving some wires around or replacing a resistor or something like that, right? Everything is encapsulated into parts, and you might replace, like in a computer, laptop, something, you might replace the battery, you might replace the memory, you might replace the hard drive, something like that. But so that's kind of what we're going to be doing with our computer programs. We're going to be trying to set things up in modules that are completely independent and self-contained that we can sort of plug in and unplug. So another just analogy that I want to throw out there is we sometimes talk about our functions as being sort of these black boxes where you create the black box, but once it's created, you don't have to know anything about what's inside the black box. You just have to know what it does if you invoke it. And then you also might need to know something about what's going into the black box and what's coming out of the black box. But the goal as we're writing our functions is to be able to write it once and then put it aside and not have to look at what's inside the function again. So just a couple of analogies to help us think about why we're using functions. So in order to do this, we're going to have to make sort of a fundamental change in how we're thinking about programming. And so I'm sort of speaking to you as if you had never used functions before, right? But so far, what we've done is basically we've said, okay, what's the first thing that we want to have happen? What's the next thing that we want to have happen? What's the third thing we want to have happen? And then we just list them down the line in order. So for example, if we were going to write a program to bake a cake, and I actually have this sort of fun little analogy in my notes. I'm just going to pull them up from a different class and do a little copy and paste. But, it's part of it. So, you know, if we were still beginning programming students and I said, okay, write a program to bake a cake, you might come up with something like this, right? Long list of all of the individual steps required to bake a cake. What I'm suggesting is that now, and when we approach a programming problem for the first time, instead of just listing out a bunch of steps, we're going to want to do something more like break it up into the big subtasks, right? So maybe start by gathering the ingredients and then mix the ingredients and then bake. Then you're done. So now we've got a basic outline of what we want to do, and then we just have to go back and specify what exactly it is we mean when we say gather ingredients. What exactly is it we mean when we say mix ingredients? So, and then I'm not going to spend too much time on this, but my hope is that it's fairly self-evident how this approach is going to help with these 4 goals that we have when we are writing our computer programs. Okay, so that's just sort of motivating things a little bit. What I want to do now is basically dive in, and I just want to do like a super simplest example I could think of where we might want to use some functions. Any questions before I dive into that part of the process? This is where we get into some actual C++ syntax. Okay. So here's what I want to do. We're going to write a C++ program that draws a box. Okay, that's our goal. Let me go ahead and just put this in a comment so that we can keep it up there and work on it at the same time. Okay, so let me actually just throw a question out there, and you can either just kind of yell out or you can type something in chat. But if we're going to be using this new sort of approach that I'm encouraging, what do you suppose would be the, I don't know, 2 or 3 or 4 steps that you would want to go through? And we're not talking about programming here yet at all. We're just talking about abstractly, right? Like if I were to try to break this job up into 2 or 3 or 4 subtasks, what do you suppose those would be? And keep in mind that what we want here is I want to make a list of 2 or 3 or 4 steps here. And then when I look at that list, I want to be able to look at that list and say, oh yeah, if I do those 2 or 3 or 4 steps, I'm going to be done with this task of drawing a box. Any suggestions?
You create a function that does each one of the lines that needs to be created.
Okay, so I would start by saying draw
Right side, right line, and draw top, draw bottom, and draw left.
Okay, draw top, draw bottom, draw left, draw right. Good. So that's a good starting point. So now I'm going to back up a little bit and say, all right, we're dealing with a console window here, right? We're not doing any fancy graphics. So really, we're going to have to start and go down one row at a time here when we draw this thing, right? So maybe draw top. I'm going to just suggest draw sides, and then draw bottom, something like that. Okay, so now this is good in the sense that I can look at this and I can say, okay, if I do those 3 steps, I'll be done. If I can define what those 3 subtasks mean, I'm done with this task. I'm kind of emphasizing that part a lot because I often see students writing their main function, and I just look at their main function, and the first thing I notice is I don't really understand how accomplishing executing those function calls that you've got in main is going to accomplish the task we're trying to accomplish. So that's just an important principle, and I'll try to stop repeating it over and over again now. Okay, so I'm going to try to refine this a little bit, though. One problem I see with this is that I've got draw top and draw bottom, but those 2 things are really doing the same task, right? So what do we want to do about that? How can we fix that so we don't have to write the same task twice?
Do like draw horizontal and draw vertical.
Okay. So let me that's great. I'm going to get us there in a sort of longer way. All right, draw row and draw column. That's also a good suggestion. So the first thing I notice is, these step 1 and step 3 are really the same. So I could say something like draw top again, but now that doesn't really work because, let me rephrase that. It would work, but it doesn't really make sense because it doesn't make sense to say that I'm going to draw the top here when really I'm drawing the bottom, right? So the principle that I'm sort of trying to get at here is, when possible, it's optimal to try to give our functions names that are more general, that describe the task it's doing, as opposed to sort of the role it is playing in the problem we're trying to solve. I'm not sure if that made sense, but so as was suggested, I'm going to call this draw horizontal line. And so now what we have is, and hopefully you can see this, is what I've done is I have separated out the name of my function from the role that it's actually playing in this particular problem, which means that now, hypothetically, I could take this same function out and use it in some other program I was writing where I needed to draw a horizontal line. And the fact that I have named it independently from its context or its role here in this program helps with that ability to reuse that code. And so for draw sides, I'm just going to say draw vertical. In fact, I'm going to try to be a more specific, draw to vertical lines. Okay. All right. Any questions or comments about what we've done so far? As you can see, I'm sort of spending some time here trying to. I haven't even gotten to any C++ syntax yet, right? I'm just sort of focused on a little bit more about some good practice principles for when you're creating your own functions. Everyone good? Okay, let's see some actual C++ code then. I hope that you all are smarter than I am, and you don't actually just type the stuff in from scratch every time, but you probably have like a file that you use as a template or copy and paste it or something. But tend to like just typing stuff in. So there it is. All right, so what we're saying so far is we want to draw a horizontal line. And the way a function call works in C++ is that a function call always has parentheses after it. That's how the compiler knows it's a function call. Whoops, draw horizontal line. Draw two lines. Okay, so there's our C++ code. We're completely done with this program now, except that we still have to go define what we mean when we say draw a horizontal line, and define what we mean when we say draw two vertical lines. Okay, so these are function calls, otherwise known, I guess the fancier term for that would be function invocation. What's invocation? There's my line. It's too long. All right. So let's work on how to actually define what we mean when we say draw a horizontal line. So here's what a function definition is going to look like in C++. In Python, we start with the word def, right? In C++, you start with the word void. Name of the function. Always have parentheses, just like in the function call. And then here's where you put the statements that are going to get executed every time the draw horizontal line function is called. So oops. Okay, someone in the chat said public static void. That sounds like Java to me. In C++, first of all, we don't have to say public because we're not inside a class. And we don't have to say static because we're not inside a class. Okay, any questions about this function definition? So I'm going to just put a comment here. By the way, this comment that I'm putting here is not a good example of how you should comment your code, right? Because and when you write comments in your code, you don't want to be explaining features of the language. You want to assume you're talking to someone who already knows C++. But I'm putting them in here just because I think it's helpful for teaching and learning. So this is a function definition. Okay. All right, should we start on draw two vertical lines? No questions? Okay, so for draw two vertical lines, it's a little bit more complex than the draw horizontal line, right? We've got to figure out how to create these two lines of output. And so I'm once again going to sort of use my top-down programming skills. That's a term that I didn't mention before, but I should have actually. Remember I was talking about this new approach to programming where instead of just listing all the steps, we try to figure out what the subtasks are. We call that top-down programming sometimes. Sometimes you may hear it referred to as stepwise refinement. Anyway, now that I have typed that, I'm going to delete that. Oh, I see a question in the chat. So count is created in the for loop. Yes, that's correct. I could have just said, whoops. And I think in the notes, you'll see it this way because I used to teach it this way just because it's a little simpler. I could have just said int count out here to declare the variable and then used it inside the for loop. But typically C++ programmers will prefer to take the shortcut and just declare it in the for loop header like that. The difference is, this is a little bit of a digression, but let's just go here for a second. If I declare count out here, then I can use this variable count anywhere in my function. But if I declare it in here, I can only use it inside my for loop. I can't later on try to use count again out here outside the for loop. But we'll be talking a lot more about that. Okay, draw two vertical lines. So I'm going to use my stepwise refinement or top-down programming again here, rather than try to get all of the details right here. So I'm going to just say for row count, it's 0, row count less than, I want 2 rows, right? Everyone see where I got the 2 rows? Okay, and now I'm thinking to myself, what I need to have happen each time through this for loop is I need to print 1 row. Okay, so again, this is just another example of sort of good programming strategy. You don't necessarily want to, try to get every detail right on your first time through. Sometimes you want to just use some pseudocode and say to yourself, okay, as long as I can insert code here to print 1 row, then I know that I have accomplished what I needed to accomplish in this function, right? So at this point, I'm feeling pretty good because I know as long as I can write that code, I'm done. A couple options here. I could just write the code and put it right in here. But a better approach would be to, let's say, I'm going to just call another function to do this code, and then I can write that as a separate function. So I like to say that in situations like this, that sometimes being a procrastinator is a good thing, right? I don't really want to think so much about that code right now. I got too much going on in my brain. So I'm just going to throw a function call in there, and then I can treat that as a separate task. Okay, so there's a function call through a function called draw 1 row. Everybody clear on how this is going to work, right? I'm trying to draw this part of my picture. And so I've got a for loop. Each time through the for loop, I'm going to draw 1 of these rows. And that's why I'm going through my for loop 2 times. If I change this to a 4, that would just mean I would have 4 of these interior rows here. Okay, so now we have to go ahead and write our draw 1 row function. And that's just going to be print an X. For loop to print the spaces between the X's. What just happened? So I want 4 spaces, right? And then after my 4 spaces, I need to print another X and null. All right, anybody want to ask a question about what's going on here, why this works? We'll run it in a second. I do just want to say, notice I am violating my good practice principle of not using numeric literals in my code. So normally I would replace these with some sort of a constant. In this case, I'm about to get rid of those anyway as we go, so I'm just going to leave them there for now, but I just want you to know that normally that would not be a good practice. Another thing I'm doing is, if you look at the style conventions, you'll see that I require 6 blank lines between functions in your code. I decided to not do that here just because I think it's helpful while we are learning this stuff to be able to see as much as possible all at the same time. In fact, I might even make the font smaller.
I have a question.
Yeah.
What is the reasoning behind making 2 different functions rather than like nesting for loops?
Well, I would go with, there's a few things. One is this function is now easier to read. One could argue anyway. Admittedly, we're doing very simple stuff here. And so I may be taking the decomposition thing to a more of an extreme than I might otherwise. But the argument would be, if I've got all of this complicated code that draws one row stuck right here in this function becomes more difficult to read. It's easier to read and understand if I factor out a function here. Another argument would be, now I've got a function named draw one row, and maybe later in my program, or maybe even if I'm writing another program, there may be a situation where I need to do this exact same task again. Now I've got this function I can reuse rather than having to write all this code over again from scratch. A third argument would be, once I separate out this code, let's say that there's a bug in my program, and for some reason, the rows are coming out with an extra space in them. Now, instead of having to look through all of this code, I can say, well, the problem seems to be with drawing one row, so I only have to focus in on this code here when I'm debugging my program.
Okay, I understand.
Okay, yeah.
Yeah, thank you.
I'm glad you asked that. Okay, let's run it and just make sure that it actually is doing what I'm claiming that it's doing. You guys can see both of these windows now, right? And let me know if anyone need to make it bigger. Oops. Oh, geez. Okay. So look at this. I should have, if I was quick, I would have pretended that I did this on purpose. So, here's what it says: use of undeclared identifier, draw horizontal line. Okay, so let's go ahead and see what that's about. Right here on this line, the compiler is telling me that draw horizontal line is undefined, undeclared. Here's the deal. In C++, just like with variables, you have to declare a variable before you use it. You also have to declare functions before you use them. So draw horizontal line, I'm trying to use it here, but I haven't defined it until down here. Okay. The way we fix this in C++ is we declare all of our functions right at the very top of the program. And this is what a function declaration looks like. And usually when we talk about this, it is a declaration technically, but we usually call it a prototype. That's the more common terminology. So we need prototypes so that we can, so that all of our functions are declared before we try to use them. So basically the rule is every time you define a function, you should remember, unlike me, to go to the top and create a prototype for that function. And the way you create a prototype is basically you just copy the function header, paste it at the top, put a semicolon at the end. Okay, so now you can see there are 3 different places to take the draw horizontal line function as an example. There are 3 different places where you're seeing the word draw horizontal line. 3 different, not places, 3 different contexts or 3 different roles of where you see that function name. You're seeing it here. Let's start here. You're seeing it here as a function call. And there, just keep in mind, this is something that students get confused about because there's 3 different contexts. So when you're using it as a function call, you don't have the word void in front. You do have the semicolon at the end. Okay, then you've got a function definition. So this is the function header is the first line of the function definition. And there you've got the word void, but you don't have the semicolon. And then thirdly, you've got the function declaration or prototype. There you've got the word void and you've got the semicolon. Okay. And then just another word about prototypes. It's a very machine sort of process. You know, you probably wonder why the compiler just doesn't do it automatically, right? There's nothing conceptually difficult at all about it other than just remembering to do it. Just copy, paste, copy, paste, copy, paste, and you're done. Very mechanical. All right, looking over here, I noticed that apparently I have forgotten to declare my row count variable also, so let me fix that. By the way, this is one of the advantages of using an IDE instead of command line, right? If I had been using an IDE, I would have gotten a red squiggly there, and I would have realized I had an error before I actually tried to compile it. All right, everyone okay so far? Let me know if you have any questions. I'm just going to try this again. Okay, good this time. And there's our box. Okay, any questions so far? All right. I'm gonna need to take a 2-minute break here. So let me, oh wait, let's see if we can chat. What does it mean if Visual Studio gives a green underline? I don't remember what the green underline means. Might mean, oh, it might mean that that function hasn't been defined. I'm not sure. Okay, so I'm going to pause recording here just for a second. Okay, so are we still good? Everyone's, my audio is still working and everything. Okay. All right, and someone did ask a question earlier about variables and other functions. Just want to let you know I am going to talk about that. Getting there very soon. All right, here's what I want to do now. Well, actually, I just want to mention one more thing. Now that we are studying functions, if you hadn't realized it before, you should be clear now that main is actually just another function. And in C++, a program like this is just a collection of functions. In one sense, they're all equal, right? I could, these 4 functions, I could, as far as the compiler is concerned, I could switch the order around however I wanted, and everything would still work fine. The only difference between the functions, for example, between main and draw horizontal line, is that main is the name of the function that C++ executes first when you tell it to execute a program. So the C++ just looks for a function named main, and it knows that's where to start. It's kind of funny that there's this word int in front of main, and we'll be talking more about that later. For now, the way I would think of it is just think of that as it really means the same thing as void, but for historical reasons, we put int there instead of void. Yeah, just go with that for now. Okay. What I want to do now is I want to make it so that instead of always drawing a box that has a width of 6 and a height of 4, like this, I want to make it so that the user enters the height and the width of the rectangle. Okay, so I might say something like, oops, int width, int height, enter width, width, enter height, height. And then let's go down and take a look at our draw horizontal line function. Basically, what we want to do now is we just want to say, well, instead of the 6 here, let's put width. Okay. Now, since for most of you, hopefully all of you, this is not your first programming class, you're probably thinking, you're probably seeing what's not going to work here. Thank you. But just to sort of look at this with new eyes, I guess I would say, this is conceptually what we want. The problem is that functions cannot share variables, right? So when I say width here, there's no variable width declared inside draw horizontal line. So that's going to give me an undeclared variable error if I try to compile it, right? So this width here is not the same variable as this width here, period. Even though they have the same name, those are two completely different variables. If you look in the computer's memory, you're going to see there's a memory location set aside for the variable width that is declared in main. And then there should be, but isn't yet, because we haven't declared it, a different memory location set apart for the variable width that is declared inside draw horizontal line. Two completely unrelated, separate variables. So here's what we have to do. In order to get this to work, I'm tempted to, let me just try compiling this just to, in case anyone's skeptical. What's going to happen if I try to declare, compile this? Undeclared identifier. Okay. So what needs to happen is I need to have a way for main to communicate to draw horizontal line what the value of width here should be. Okay, so excuse me, when I am writing my draw horizontal line function, I'm thinking, in order for me to do my job, and so I'm pretending to be the draw horizontal line function, which I actually think is a useful technique when you're learning this stuff. If I'm the draw horizontal line function, what I need in order to do my job is I need to know what the value of this variable width is. So what I do is I'm going to put that inside these parentheses here. And what that means is, okay, when you call me, I'm the function draw horizontal line. I have a job to do, but when you call me, you have to send me the information that I'm going to put into this variable right here. And then I'll know what to do with it. Okay. This is a parameter. And further, I'm going to say, in general, in C++, the rule is that a parameter is always a declaration. Okay, this is actually one of those, like, I would burn this in your brain, okay, because a lot of students will get confused about what the syntax is for what goes here. And the answer to that question is the syntax for what goes here is exactly the same as when you are declaring a variable, right? No semicolon, but other than that, the syntax is exactly the same. And we're going to quickly get into some situations where the syntax is more complex. So that'll be an issue. So, but anytime you're not sure what the syntax should be here, just remember that what's going here is a declaration. And it's also a declaration in the sense that a declaration actually allocates or sets aside a memory location in your computer's memory for this variable, okay? All right, any questions? So at this point, I think I have a program that will compile. Oh, no, not quite. Other half of this communication, right? When we're setting up this communication, main is going to provide some information to the draw horizontal line function. Draw horizontal line has indicated what that information is that it needs. So when I call draw horizontal line, I need to send that information. So what I want to do is whatever's being stored in the variable width, that's what I want to send down. Okay. Any questions? All right, just one more comment, just for fun. What goes in here does not have to, the fact that these have the same name is coincidental at this point. In fact, I'm going to work on that in a minute. And the other thing is I could actually just put a number here, right? I could say 8. And that means I'm sending the number 8 down to the draw horizontal line function. The draw horizontal line function is going to catch that value and put it into this variable that's being declared here called width. All right, here's the next thing I want to say, which is just a matter of good practice more than a matter of correct syntax. We have a function here called draw horizontal line. Having a parameter named width actually makes no sense here because lines don't have widths, right? When we called this width, the reason we did that is because we were thinking about this function in its role in this particular program. But if we're thinking about this as a generalized function named draw horizontal line, what do we need to know to do our job? And last time I answered that question, I said, well, I need to know the width of the box. But that's a bad answer, really, because I don't want to be thinking about the fact that this is part of drawing a box. I just want to know, I'm drawing a horizontal line. What do I need to know? And I'm going to say, one answer would be, well, I need to know how long the line is. In this particular case, we're making a line out of x's, so I'm going to call that num x's. Okay, so I did that partly just as a matter of getting in good habits, but also to just double demonstrate the fact that this variable and this variable are two completely unrelated variables, regardless of what I name them, right? I could name it width, I could name it num axis. Sometimes students ask me, well, should I name it the same or should I name it something different? And the answer is name it whatever makes the most sense. And sometimes that's going to be the same, and sometimes that's going to be different. All right, any questions about this so far? Just checking to see if I forgot to say anything here. All right, so I'm just gonna wrap up this example now. So draw two vertical lines. Let's forget about everything else for a second and just think about if I am the function draw two vertical lines. So my job is to create this part of the picture. What do I need to know to do my job? Anybody want to take a shot at that? Okay, right. I need to know how many rows to make. So I'm going to say num rows. Whoops. Okay. And then exactly how far apart the lines will be. It actually turns out that I don't need to know how many vertical lines, right? Because it's always two. But that would be an interesting problem, right? If we could write a function that draws any number of vertical lines. But I need to know how far apart the lines will be. If that didn't make sense, think about this just as if, you know, I was handing you a piece of chalk and telling you to go up to the chalkboard and draw two vertical lines made out of X's. And what do you need to ask me? What do you need to know in order to do that job? Well, you'd need to know how many rows of X's there's going to be, and you would need to know how far apart to put those X's. How do we want to quantify that, right? We don't really want to say int how far apart, right? We could, but what is it exactly that we need to know? I'm going to tell you. How many spaces to put between the two lines, right? If I know how many rows of X's to put and how many spaces to put between them, that's all I need to know. And so now inside here, instead of 2, what do I want right here? How many rows do I want to print? Num rows, right?
Num rows.
Okay. Now I'm actually doing, I might have done that in slightly the wrong order, right? Probably before I started writing the code inside draw two vertical lines, I should have gone back to main and made sure that main was passing the correct information down to draw two vertical lines. So let's go back there. Draw two vertical line, I'm sorry, main needs to tell draw two vertical lines how many rows to print. How many rows do I want it to draw? From the I'm main now. I'm pretending to be the function main. I'm going to call draw two vertical lines and tell the draw two vertical lines function to do its job. I need to tell it how many rows to draw. How many rows should it draw?
Height.
What do you think about that? What is height going to be in this picture? So the height in this picture is 4, right? I suppose that could be a little bit ambiguous. So if that wasn't clear before, I'm telling you that the height of the box that we're drawing means how many X's tall the sides are. So in this case, this would be have a height of 4. So how many rows do I want? So if the height is 4, I want 2 rows, right? How many rows in here do I want if the height is 7? Well, in that case, I would want 5 rows in here, right? So yeah, height minus 2. Oops. Okay, and then the next question. When I call draw two vertical lines, I also have to tell it how many spaces to put between the lines. So how many spaces, if I'm main and I'm telling draw two vertical lines to draw this stuff, how many spaces do I want between the lines?
Width -2.
Right. Okay. All right, so that's good. Let me just make an observation here. Probably many of us, if we had been writing this from scratch and I had not thought carefully about it, and I just said draw two vertical lines, and when I call to draw two vertical lines, I'm going to send draw two vertical lines the height and the width, right? And then I would have had a function called draw two vertical lines, and maybe these would have been called height and width. But that wouldn't really have made sense because when I'm drawing two vertical lines, it's not a height and a width that I'm talking about. It's a how many rows do I need and a how many how many spaces do I need. So just an encouragement, and we could have made that work, right? We would have had to say, height -2 here. But that would have made less sense because height doesn't really have a meaning in the context of draw two vertical lines. So just another encouragement to sort of think carefully about how you're dividing up these tasks. All right, so I think we have one more step to go here. Draw one row in order to do my job. And now notice every time I'm doing this, what I'm doing is I'm setting up the required communication between two functions. And the way I do it is I always start by looking from the perspective of the function that is being called and what I need in order to do my job. Okay, so if I draw one row, what do I need to know in order to do my job of drawing one of these rows? And the answer is, I need to know how many spaces to put between the x's, right? So I'm going to say, okay, I need to know, if you call me, you need to tell me how many spaces to put between the rows, between the x's, sorry. Okay, and so that means here, num spaces instead of 4. And then back up here, so now I have finished figuring out what to do in the called function, the function that's being called. Now in setting up that communication between two functions, I need to go back and look in the function that is calling, or the calling function, and say, okay, what information do I need to send when I call this function? Well, I need to send num spaces. Okay, so in this case, it turns out to make sense to just have these variables be called the same thing. But keep in mind, repeating myself here, but keep in mind, this variable num spaces and this variable num spaces are two completely separate variables in your program, and also in the computer's memory, there's going to be two completely separate memory locations. Don't try to think of them as the same variable. The only reason that this variable turns out to have the same value as this one is that just happens to be what value draw two vertical lines is sending to draw one row. All right. Anyone want to ask a question? Okay. One more thing, and this is usually the very last thing that you do before you actually compile your program. In my case, it actually turns out I usually try to compile my program first without doing this, and then I remember that I forgot to do it. And that is I need to update the prototypes, right? I need to go back and say, okay, this prototype changed, this function header changed. So I'm going to recopy, paste. Same thing here, recopy, paste, recopy, Paste. Okay, and now hopefully this will actually work correctly. File, execute. Let's try, what should we say? Let's try a width of 7 and a height of 9. There's my box. Hopefully, I guess I probably should have used a smaller number so it wouldn't be so hard to double check, but 1, 2, 3, 4, 5, 6, 7, 8, 9 is the height, and 1, 2, 3, 4, 5, 6, 7 is the width. So it looks like we are in good shape. Okay. All right. Since I have a couple of minutes left, I just want to mention one other thing. In C++, you, as with any language that I'm aware of, I'm sure there's exceptions to this, but in C++ anyway, you can actually have variables that can be used from any function, and those are called global variables. So I could have said int width out here above main, outside of any function, and then that function could be used from inside any function in my file. Generally speaking, that's a really bad idea. So in this class, we will not ever be using a global variable. You might need to, you need to understand how they work, because there might be an exercise where I ask you to tell me what's going on. And obviously, you might see someone else's code and they use a global variable. Basically, you just need to know that because this is here, I could access that variable from any function in the file. But we're not going to do that. Okay. All right. Anybody want to ask a question before we're done? All right. So the plan is on Wednesday, I'm going to wrap up talking about functions, and you're going to do a little lab. I guess it'll be lab 3, right? That is primarily a review of functions and parameter passing. And then we'll move on. All right. I will see you all on Wednesday.